This is chapter 3-2. This is recording number 6. Okay, so let's read this here carefully. What it's saying is that this theorem can be used to find the minimum percentage values, the minimum percentage of the data values. What percentage? Will it be half of them? Will it be 25% of them? Will it be 30% of them? Okay, what will it be that will fall between any two given values? Okay, now that seems a little strange. The language is hard. Okay, so let's just take an example and we'll bounce back and forth and we'll see that it's not as hard as it looks. So we're talking about a travel allowance here. The mean, the mu or the x bar, whichever you want to say, the x bar is 25 cents per mile. The standard deviation was 2 cents. So it's 25 cents is the mu or the x bar. So it's 25 cents is the x bar, and the s, the standard deviation, is 2 cents. So 25 cents and 2 cents. What is the minimum percentage of all the data values? What percentage of the data values will fall between 20 cents and 30 cents? Now that makes sense, right? I mean, your 25 cents is the average, so some percentage of all of the data points will be between 20 cents and 30 cents, right? Okay, so what's it going to be? What percentage of the data values will be between 20 cents and 30 cents? And now, the reason we say it's the minimum percentage is because Chebyshev's theorem deals with, and we'll go back up here. I'm going to show it to you one more time here. Okay, it talks about at least. So the minimum is blah, blah, blah. Okay, so that's why we say at least, or we say the minimum will be there. Now, the key to understanding this is the following. This sentence right here says, Chebyshev's theorem developed by blah, 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 specifies, in other words, it tells you, so it specifies the proportions of the spread, how things are spread out. But here's the key thing, in terms of the standard deviation. So what it's telling you is that the standard deviation is like a ruler. Now, just like if I said to you, I'm going to measure your height, I'm going to use a foot-long ruler. I'm saying I'm going to measure your height in terms of this ruler, right? In terms of the foot-long ruler. That's what they mean when they say in terms of the standard deviation. What is it we're using as our ruler? We're going to use the standard deviation as our ruler. Just like if I said I'm going to measure your height, I would tell you, what am I going to use? I'm going to use a foot-long ruler, as opposed to saying I'm going to use a yardstick, or as opposed to saying I'm going to use, a meter. I'm going to use a measuring tape that uses meters. I have to tell you what my measuring device is in order to have this make any sense. Okay, so that's what's going on here. Is we're using the standard deviation as my ruler. K is telling you how many of those rulers are we using. So when I say I measure one of you young men, and I say, okay, you are 5 foot 10 inches. What am I saying? I am saying that you are 5 rulers, and then the 10 inches is 10/12ths of a ruler. 10 divided by 12 is 0.83. Okay, so I'm saying you are 5 rulers and 0.833 rulers. So it's 5.833 rulers is how I'm measuring you. That translates out to be 5 feet 10 inches. Okay, so that's what the K is just telling you how many of these rulers are you away from the X bar. All right, so now let's look at that example here, the travel allowances again. So the mean is the 25 cents. The standard deviation is 2 cents. Find the minimum percentage of the data values that will fall between 20 cents and 30 cents. Now, I didn't draw a cartoon. For crying out loud, take my advice. I'm an old man. I give good advice. Draw cartoons on all of these problems, okay? So draw your cartoon, all right? Now, how do we go about this? We subtract the mean from the larger value, okay? The 30 cents, we're interested in between 30 cents and the mean. What's that delta? Delta means what is the difference? Okay, delta is difference. It's a mathematical term. We mean difference. So it's 30 cents. Take away 25 cents is 5 cents. And then now this step right here, this step 2, I think you're going to need a little help with. Divide the difference by the standard deviation to get K. Now don't just memorize formulas, because in a moment of stress you're gonna forget the formula. Where does this come from? How do we get this? Why do we divide the difference by the standard deviation to get the K? Well, I wrote it out for you. Here it is. Okay, so here's example 3-26. Okay. Whenever we're dealing with Chebyshev's theorem, we want the proportion that falls within K standard deviations of the mean. So think of the standard deviation as a ruler, like I've said before. It is measuring the delta. This is the symbol for the delta. It is measuring the delta that we are interested in. Using my analogy, if the delta is 6 feet and the ruler is a foot long ruler, we say that the delta is 6 rulers in length. That's the, it's 6 feet long, right? So how many rulers is it? It's 6 of them. So K is 6. Okay, now this symbol right here, give me 1 second, I'm having a technical difficulty. This symbol right here, it's like a little triangle, or a little pyramid, I guess you'd say. A little circle, a little circle, a little circle. That stands for therefore. That's a very, very common mathematical symbol. It means therefore. All right, so we say that the delta is 6 rulers in length if I'm measuring something that's 6 feet long and I'm using a foot-long ruler. So that's my comparison, or that's my analogy. So therefore, what we say is the delta is equal to K times S. It's K times S, because S, my standard deviation, that's the ruler that I'm using for Chebyshev's theorem. Well, just by manipulating this, I can divide both sides by S, and what do I get? That K is equal to delta over S. Just divide both sides by S, okay? So K is equal to delta over S. Well, that's exactly what the author says right here. K is equal to the standard deviation, I'm sorry, the delta, the author says the difference, that's the difference that we found right here, the delta divided by the standard deviation, that gives me what K is. Now remember, K does not have to be an integer. It does not have to be a counting number. It can be, just any old number as long as it's bigger than 1. So K is equal to 2.5. So what we're saying here is that K is 2.5. So 2.5 times this delta tells you how far away are you from the mean in terms of, or using the ruler of, the standard deviation. Okay? All right, so K is equal to 2.5. We're going to use Chebyshev's theorem to define the percentage. Okay? So if it's 2.5 is our K, 1 subtract 1 over K squared, that gives me this, 1 over, is 1 subtract 1 over 2.5 quantity squared, that's 1 subtract 1 over 625 equals, and just plug it into your calculator, boom, it's 80.84. 0.84, if you multiply that by 100, that gives you 84%. That's just to translate it. Now, it's the same number. 0.84 is exactly the same as 84%. But for us human beings, usually we're a little more comfortable dealing with percentages in a context like this. Okay, so what this is saying is that at least 84% of the data values will fall between 0.20 and 0.30. Okay, now cartoons are great. I'm telling you, draw your own cartoons. Let's use one of the author's cartoons to see if this kind of makes sense here. We're saying that K is 2.5, right? So let's look at this cartoon up here they gave us, okay? This cartoon was saying, hey, listen, if you're at 2 standard deviations, if k is 2, okay, it's x bar plus 2 standard deviations. It's plus or minus, so it's x bar plus 2, x bar subtract 2. That's right here. At least 75% is between here and here, all right? So then similarly, this other part of the cartoon is saying, hey, x bar plus 3 standard deviations, x bar subtract 3 standard deviations. How much is between here and here? Well, there's at least 88%, okay, 88.89%. Okay, so now we're at 2.5 standard deviations. So it's going to be somewhere between 75% and 88%, just looking at this cartoon here. And that's exactly what I got. I got 84%. I got 84%. And that's consistent with what we have here. It's between 75 and 88%. It's going to be 84%. All right, so draw your cartoons. I'm telling you, if you don't draw your cartoons, you're not going to get this material. Okay, so that's enough. I'm almost out of this on this recording. So let me end this recording, and then on the next recording, we'll get started with this so-called empirical, also known as the normal rule.